Scala is a programming language, a general purpose programming language just like Java or C Sharp or C++. You might be wondering whether there really is a need in this universe for yet another programming language. Plenty of folks reckon that there is. Scala was developed at EPFL in Switzerland in around 2004. Development work on the language had started a few years before then. From the get go, Scala was developed as an attempt to build on Java's shortcomings. It was meant to be a better Java. Famous last words, you might say, but Scala has actually gone some distance towards fulfilling that promise. Scala is object oriented like Java, but it also offers a very high level of functional programming support. Java actually did add a whole bunch of functional programming support in 2014, but that was in a pretty late edition of Java, Java 8. Java 8 has support for Lambda expressions and a whole bunch of other functional constructs. Scala had support for these from the get go. And in fact, functional programming is as integral to Scala as is object orientedness. One important barometer of this is the fact that Scala supports first class functions, closures, static typing, currying, and pattern matching, all of which are generally recognized as the hallmarks of a proper functional programming language. There have been plenty of languages that have attempted to become the better Java or the next Java, and there are lots of these languages that have not really seen the light of day. Scala has proven to be an exception. Scala is widely used, particularly in applications such as machine learning, especially with Spark. Apache Spark is a distributed computing framework that's really powerful for a whole bunch of machine language type of applications. And Scala has been instrumental in the development of Spark. Functional programming lends itself inherently quite well to parallel processing. Operations such as mapping, reducing, applying lambda functions, all of these kind of come naturally when you're thinking in a functional paradigm. They also come naturally when you're working in a parallel computing framework or a cluster computing framework. And that's why Scala, with its robust combination of object orientedness and functional programming, has proven to be a better Java in many ways. If you've done some JavaScript programming, you'd be familiar with the idea of first class functions. We'll have more to say on these in a little bit, but first class functions serve as the foundation of closures. First class functions and closures help one to ship code to different nodes in a cluster and have that code do what it needs to, even in the new environment. Closures, in a sense, are functions that carry around their scope. This is one of the key ideas of static typing. Closures come in handy in JavaScript because code can be shipped from an arbitrary server to a client and still be relied upon to do the right thing. Closures in Scala are basically used for the same purpose. Code can be shipped to a whole bunch of different nodes, and once again, they carry around with them all of the information required for them to do their thing. We'll have a lot more to say on the subjects of first class functions, closures, and currying later on in this course. In addition to the many functional programming paradigm related features that Scala offers, Scala also has some other characteristics that are worth talking about. It can be used as a pure object oriented language, and it is a pure object oriented language. It is explicitly designed to be syntactically concise. It includes operator overloading, a language feature present in C++ but not really present in Java. And it also can be used either in a compiled manner or in an interpreted manner, depending on whether you want to use it for rapid prototyping or for serious long term development. Let's cycle through these features one by one and make sure we get what they're all about. Scala is pure object oriented because everything in Scala is an object. There are no value types. This means that unlike in Java, there are no primitives and no wrapper types required specifically for non-object types. All types whether they are strings or doubles or ints or whatever, are all represented and are all available as objects. This means that you do not have to deal with the conversions that come with boxing in Java. However, Scala does have a distinction between immutable and mutable variables. We'll have more to say on this in a bit. One implication of this pure object oriented nature of Scala is that functions are objects too. And this goes back to the point about functions being first class citizens in Scala. As in JavaScript, functions can be assigned, which means that they can be R values in an assignment statement. They can be passed around via variables returned from functions and treated just like any other data type. Next up, let's talk about syntactic concision. Scala has made a bunch of little choices in order for it to be more syntactically concise than Java. This may or may not be something that strikes you as an advantage, but in general, this is just the design choice that the Scala language developers made. Type inference is important. Scala has a compiler that allows it to infer a whole bunch of stuff: semicolon inference, type inference, specifying arguments using a placeholder syntax. All of these lead to the fact that Scala generally requires a lot fewer lines of code than Java does to accomplish similar stuff. Once again, from the point of long term maintainability and readability of code, this is a mixed blessing. It's hard to argue that syntactic concision makes for very long term maintainable code, but in any case, that's the choice that they went with, and that's how the language is set up. Operator overloading is a feature that is quite important in C++, but is not present in Java at all. If you're not familiar with what operator overloading is, well, it's basically just a way for classes to redefine specific operators, such as say the plus or minus or equal to operator, and treat these as methods of a class. And so, for instance, you might have a class representing a complex number. This might redefine the plus operator such that it takes in another object of type complex number and returns a third object whose real and complex parts are equal to the sum of the real and complex parts of those two objects passed in. Operator overloading is a very cool and very widely used feature in C++, and it's now coming back with a sort of retro chic. Next up is the fact that Scala can be both compiled or interpreted, and what's more, it can be compiled either to Java bytecode or to JavaScript. Scala is in this way a rare example of a programming language that can rely on or that can be used either in compiled or interpreted mode. By default, Scala runs using a JVM and its code is compiled to bytecode. This gives Scala seamless and flawless interoperability with Java. You can run a Scala program anywhere that you would run a Java program. And you can also use all of Java's classes and libraries directly in Scala. This is a pretty powerful advantage of interoperability with Java. But there's more. The Scala compiler can also compile to JavaScript. This gives Scala interoperability with JavaScript as well, which could become pretty significant depending on the specifics of your use case. Scala also offers an interpreted mode. It also offers a kind of command line interface where you can type out your commands and have them interpreted and executed on the fly. This is an important bit of functionality for folks interested in rapid prototyping. Read, evaluate, print, and loop or REPL languages such as MATLAB or the statistical package R are really helpful as prototyping tools. And perhaps the big daddy of all prototyping tools is Microsoft's Excel. That has become the benchmark for the level of feedback and speed of prototyping that an environment ought to provide. Scala's having this interpreter allows it to be used as an REPL language, and this is pretty significant for folks who need to develop stuff quickly before they then go ahead and set it up as production level code. Collectively, all of these characteristics, along with the functional programming support provided by Scala, define the language in a sense. These are some of its defining characteristics. Let's now go ahead and actually start to do stuff with Scala. That will help make things seem a lot more concrete.